Okay guys, so today we are looking at exact ordinary differential equation. It is also a first order ordinary differential equation, and these are the few things that you need to know. So I shall talk about them, and we shall solve one example applying the concepts so that we can see how we can solve an exact ordinary differential equation. So the first thing that you need to know is the standard form. So this is the standard form. So as you can see, you have a formula. As you can see, you have got a function of m, x, y. That means that function comprises of x and y, dx plus n, a function of n, x, y, dy is equal to 0. So if you see your equation that it can take this form. For example, you have to, sometimes the equation may not necessarily be in that form, but you have to convert it to be in that form. So if you see that it's in this form, then you should know that it may be an exact ordinary differential equation. So it may be means that it may not be also. So you shall see what I mean by that. So the second thing is the test. So you have to test. If it's in this form, then you have to test whether that equation is exact or not. So you test. So you test by partially differentiating the function of m with respect to y. Is partial differentiation, and you shall also differentiate a function of n with respect to x, and you compare the result. If they are the same, then it is exact. If they are not the same, then it's not exact ordinary differential equations. Okay, so the third thing would be to, if now assuming that it's exact ordinary differential equation, you proceed by solving it. Just integrate m with respect to dx. So you just integrate m dx. So as you can see, the other function, which is y, becomes a constant. And you simultaneously you shall also integrate n dy. So then you shall write your answer as f of x, y. This is a function of x and y is equal to c. So this f of x and y will be the common, you shall write the common entities once, and you write the rest, then you equate it is equal to c. So let's look at an example how we can solve exact ordinary differential equation. So you have got this equation. You should find the solution for this ordinary differential equation. X plus sine y dx is equal to 2y minus x cos y dy. So is it possible to convert this into this standard form? Let's see. So for example, I can take this to this side so that I can have 0 here. So I'll have x plus sine y dx, then it will be minus 2y minus x cos y dy is equal to 0. So, but here remember we need to have a positive sign. So can we still do something to this one? Like, let's see, if I can distribute this minus inside, then I'm going to get x plus sine y dx. So this will be, if I distribute here, if I distribute here, it will be positive. So I can put positive here. So this will be positive. So x cos y, and this will be minus 2y dy is equal to c, is equal to 0. So as you can see, this is indeed in the standard form. So let's test if this is an exact ordinary differential equation. So let's try to find the partial derivative of m with respect to partial derivatives of m with respect to y. For this one, as you can see, this is m. So we are differentiating with respect to y. That means x becomes a constant. So this is a constant. So differentiation of a constant, it's 0. So you can remove it's 0. So differentiation of y, of sine y, differentiation of sine, that's cos y. Yeah, that's cos y. So let's now differentiate this one partially. So the differentiation of n with respect to x, like that. So as you can see, that means our y is constant, is partial differentiation. So this y is constant. So I will differentiate x, which is 1. So here it will be a cos y for this part, and this is all constant, so it's 0. So as you can see that this is equal to this, then this is exact. So now let's solve as exact ordinary differential equation. We shall integrate simultaneously m and y and n. So the integral of n is, this is n. So I will put dx, and the integral and the integral of n, it will be x So let's see. If I integrate this with respect to dx, that means my y is a constant. So if I integrate x, it will be x squared over 2. And this is a constant, so I'll take it out. So it will be sine y and then x. It will be x sine y. So because it's integration, that means you have a constant of integration as f of y. Why? Because when you're integrating, as you used to do when you differentiate, when you integrate, you used to have a constant of integration. So because we assume that we may have left some function of y, because we assume that y is a constant here. So you just have to put like that. So let's do this side as well. So if you integrate this with respect to dy, that means your x is constant. If this is constant, I can take it out, so it will be x. If I integrate cos y, integration of cos, it's sine, so it will be sine y, and integration of y here, so this will be 2, and then this will be squared, that means divide by 2, and this will cancel, and you have the constant. So to write your answer finally, your answer will be f of xy is equal to c. So you shall take things that are common, you write them once. So to me here, this and this is common, so I shall write it x sine y. I shall take this x squared over 2, and this minus y squared over 2, and this is equal to c. So that's how you shall present your answer